5.2. We're talking about inverse functions. I want you to pause the video and just think about, what do you remember about inverse functions from Algebra 1 and Algebra 2? So we talked about them a little bit there, and just pause the video and think about, what do you remember about inverse functions? Okay, some things you might remember about inverse functions. A big thing is you switch the x and the y. Okay, so if I have the point 1, 2, the inverse of that would be the point 2, 1. Okay, so if I want to graph the point 1, 2, the point 2, 1 would be that inverse. Okay, those are inverses of each other. The inverse of negative 1, 3 would be 3, negative 1. Okay, so negative 1, 3, the inverse of that would be 3, negative 1. Okay, and you notice those are reflections across this line here, y equal x. Okay, so those are some of the things, and even if you have an equation like the inverse of y is equal to x plus 2, the inverse of that would be x equals y plus 2. Okay, so maybe you remember some of those things and you can solve for that there, solve for the y. So those are inverses of each other. So maybe you remember that from Algebra 1, Algebra 2, maybe not. We're going to talk a little bit about that, and then I'll also maybe go a little bit more in depth with things. Okay, so inverse functions, inverse operations. Okay, the opposite of multiplying by 8 is to divide by 8. Okay, so those are opposite or inverse functions of each other, operations. You can kind of think of it this way. If I have f of 12, if I plug a 12 in here, I get 96. And the inverse, if I take my answer here, my g of it, right, I plug that in there, I get 12. So the x becomes x and y becomes the y and the x. Okay, the x and y. So they basically just switch around. Okay. Okay, so first of all, in order to have these inverse functions, we have to know that they are one-to-one functions first. So one-to-one functions. So if you remember back, whether something was a function or not, okay, just for basic function test, okay, back in Algebra 1, if you remember, if I draw vertical lines and it only goes through once, then yes, it is a function, right? So if I have this, yes, that is a function, okay? If I have this, no, that's not a function, okay? So we use our vertical line test to tell if something's a function. Now, more particular than that is a one-to-one function, okay? Here's kind of the definition of it. If A is not equal to B, then f of A is not equal to f of B, or the contrapositive of that. If A is equal to f of A is equal to f of B, then A is equal to B. Okay, basically is this. Okay, we can use a horizontal function, horizontal line test, and same thing as the vertical line test. If it only goes through once, then yes, it is. Okay, yes, it is one-to-one. Okay, also with this graph here. If I look at this graph, okay, my horizontal test goes through twice. It is not one-to-one. Okay, so that's one way to test. The other way to think about it is this. F of A and f of B. Okay, so if I plug an A into this, I get negative 4A plus 12. Well, you can't see that there. Move over. And if I plug a B into this, I get negative 4B plus 12. Okay, if I subtract 12 from both sides, I have negative 4A is equal to negative 4B. And if I divide by negative 4 on both sides, I get A equals B. Okay, so kind of by our definition up here, f of A, if those two are equal, then A has to equal B, which it does here. Okay, so, and also the horizontal line test, if it passes through once, then yes, it is a function. Okay. Okay, with this one, say we just pick a number like f of 3 and plug it in here. Okay, so 3 squared is 9, 25 minus 9 is 16, so the square root of 16 is 4. Okay, if I also do f of negative 3 squared is 9, right? So it would be the square root of 16, which is 4. So at negative 3, 4, and at 3, 4. Okay, so whenever those repeat like that, okay, if I plug in some different values for x and they get the same y value, it is not going to be a one-to-one function. Okay, so horizontal line test, if only once, it only passes through once, then yes, 1 to 1. Okay. Okay, so is this one 1 to 1? If I draw a horizontal line, so first of all, yes, it is a function, but it's not a 1 to 1 function because it has not 1 to 1. Okay, and the next one here, if I look at this one, if I draw horizontal lines, it only goes through once, so yes, it is 1 to 1. Okay, so that's the first part. First, identify if it's 1 to 1 function. Next, we can talk about the inverse of it if it is a 1 to 1 function. Okay, so functions are inverses if, okay, we can kind of think about a couple things. The analytic way of proving something is a function is to say that f of g of x, when I work that out, it'll equal x, and if I work g of f of x out, that will also equal x. Okay, so if I have these two functions, I want to prove they're inverses of each other. Remember how to find f of g of x? Remember, you take your g of x function, okay, we take that and we plug it in right here, right? So that would equal cubed root of x plus 1 cubed minus 1. Okay, cube and cube root cancel out, so I have x plus 1 minus 1, which is x, so we're good there. We just found f of g of x. G of f of x, okay, I got to take this and plug it in there now. So take this, plug it in there, it's the cubed root of x to the third minus 1 plus 1. Okay, if I add those two together, I add the cubed root of x to the third, do this cancel, cube and cube root cancel, I get x. So yes, they are inverses. Okay, if I test the next one here, okay, if I find f of g of x, so take this, plug it in right here, so I have 3. Okay, if I distribute through here, the 3's cancel, so I have x plus 7 minus 7, which is x. And if I find g of f of x, okay, take that and plug it in there, so it's 3x minus 7 plus 7 over 3. Those cancel, I have 3x over 3, which is x. So yes, they are inverses of each other. Okay, the next ones here, we want to determine if they are 1 to 1, and if they are, then we want to find the inverse. Okay, so this one is not 1 to 1 because of these points right here. So if I put the point 1, 2, and 2, 2, right, it fails the horizontal line test. Okay, so this is not 1 to 1. Okay, this one here though, okay, looking at all these points, they're all going to be different there. So this is the notation we use. We say the inverse of g, okay, and remember the inverse, we switch the x and the y. So 3, 1 becomes the point 1, 3, 0, 2 becomes 2, 0, 3, 2 becomes, sorry, 2, 3 becomes 3, 2, and 0, 4. Okay, and that's how you find the inverse. Okay. The next part is I want to actually find the inverse of an equation. So once again, we just switch the x and the y. So this is like your y, right? So we switch the x and the y. Okay, and that's the inverse, but we don't want to leave it in that form. We want to graph it. We want to solve for y. Okay, so we subtract the 5 over and then divide by 2. Okay, so there is our inverse. And let's put it with the correct notation. We would say f inverse of x is equal to the 1/2 x minus 5 halves. Okay, so this would be the correct notation we want to use, f of inverse of f. Okay, and let's graph them. Let's see how they relate. So this first one, start at 5, go up 2 over 1, right? The other one, you start at negative 2.5. And you go up 1 over 2. Something like this. Okay. And we kind of, you did this back in Algebra 2, but I don't know if you remember or not, but we have this well, I'm going to ask you later, see if you can put it together, okay, after we graph them all. Okay, so this one, x squared plus 2, you know it shifts up 2, right? So there's that graph. If we find the inverse, we switch the x and the y. And now we got to solve for the y. So bx minus 2 is equal to y squared. Got to take the square root of both sides. Okay, so don't forget your plus or minus there. Okay, so this one, actually if we notice it right away, this is not 1-to-1. Okay, so it's a not 1-to-1 function, therefore there is no inverse to it. Okay, because what you see here is, so it's not 1-to-1 because it fails the horizontal or upward line test, right? So what you see here, it actually creates two different functions. You would have this function, which would be the positive one of it. Then you'd have this one, which is the negative of it, which is still the reflection, right? It's still the reflection that we're looking for, but it's two different. So since it's not a 1-to-1 function, it doesn't have a single inverse. It has two equations that make up the inverse of it, but not a single. Okay, so we would say there's no inverse to this one. Okay, there's a little blip in the video here, so I am redoing this part. Okay, so we switch the x and the y here. To solve it, take the cubed root of both sides, and then you can add the 2 over to the other side. Okay, and if you graph this, you know it's a cubed root, so it looks like this, and plus 2 shifts it up 2. Okay, you have this line y equal x that it is a reflection across. It's not completely great at graph there, but you get the idea. Okay, so how do inverses relate to each other graphically? They are reflections across the line y equal x. Okay, now does everything have one? Okay, well, have an inverse. Well, no, we said if it's not 1-to-1, there's not really an inverse, right? But also sometimes we have to restrict the domain. So if you think about this square root of x plus 5, that's this graph right here. Okay, so you know it's minus 5 shifts left 5 and comes up like this, right? Okay, we've graphed those in the past. Now, if you think about that, that has a domain that starts from -5, goes through infinity, has a range that starts at 0 and goes up. Okay, now if I find the inverse of that, so switch the x and the y, and square both sides, and add the 5, subtract the 5 over, I get this. Technically, that graph is this whole thing, isn't it? Okay, it's a parabola. But the whole parabola is not the inverse of this original function. This original function only went from had a certain domain and range. So if you think about this one, think about what's going to be the inverse. The reflection across here is going to be this red part. So this red part is the only part of it. So we don't have, this part's not really part of it. So we have to restrict the domain. So it's not this whole graph, it's just that graph with the domain from 0 through infinity. Okay, and it would have a range from -5 to infinity. Notice the domain becomes the range and the range becomes the domain, right? Because we're just switching the x and the y's together. Okay, the next one, find the inverse of rational. We've talked, last chapter was about rational functions. Okay, so if you think about this graph right here, I have that one in blue right here. We know that -1, so shifts it over to the +1, right? And I know that equal degrees, so 2 over 1, so it goes up here at 2. Okay, so we have the graph there. If I find the inverse of that, so sorry, domain, it's all numbers but 1 can't work, and the range, all numbers will work except for 2. Okay, so finding the inverse, I switch the x and the y's, so the y becomes an x, these x's become y's, cross multiply, that times that is equal to that times that, distribute through. Okay, I'm going to take this 2y over that side and this -x and add that over to this side. I can then factor out a y from both sides, and then I can divide by this over to the other side to get y by itself. So I can say the inverse of x is equal to that function right there. Okay, so if we graph that one, I have that one in red here. So I know that my domain x can't equal 2, so right here at 2, it's an asymptote, and degrees are the same, so 1 over 1. I know my horizontal asymptote's at 1. Okay, notice that's just switched, isn't it? Okay, from before. So we have the domain and range that are just opposites of each other. Okay. Now, how are these used? Okay, or how have they been used? They've been used for encoding and decoding messages. Let's say that I'm going to send a message to somebody, and we both know this original equation we're using. If somebody intercepts it, they're going to have a hard time decoding the message and knowing what it is if they don't know what this equation is. Okay, so what we do, we have the letters of the alphabet, and match them up here. So if I take the word calculus, put 3, that's a third, A is the first one, L is the 12th one, right? Okay, etc. Keep going. Now, if I take these and plug them in here, 3 times 3 is 9, plus 1 is 10. Plug the 1 in. 3 plus 1 is 4. Plug the 12 in. 36 plus 1 is 37, etc. We get this. This is the message that is sent. Now, if somebody intercepts that, they're not really going to know what that means. Okay? But if I get the message and I knew what this was, I can find its inverse. So switch the x and the y from this and subtract and divide. Okay, so if I know this, now if I get the message, I can plug this in. 10 minus 1 is 9, divided by 3 is 3. 4 minus 1 is 3, divided by 3 is 1. 37 minus 1 is 36, divided by 3 is 12. Okay, so you notice we're getting the same letters back that we started with, right? So we decoded our message there.